Hi friends, welcome back to our channel Physics Tutorial. Today we are going to discuss some previous question papers of class 12 Physics CBSE board examination. So now we are going to start with the questions of September 2022 board exam. Okay, if you like the video, please like, share and subscribe. Can we move to the video? The first question is, according to Coulomb's law, which is the correct relation for the following figure? So here we can see a figure, and according to that Coulomb's law, which option is correct for the figure? So that we have to find. So here we can see two charges, that is Q1 and Q2, and here we have two forces, that is F12 and F21. F12 means the force acting on the first charge, that is Q1 due to Q2, and F21 is the force on Q2 due to Q1, and we can see that both are attracting each other. Okay, that means F12 and F21 are attracting each other. So in this case, which of the following option will be the correct option? So the options are A, Q1 Q2 greater than 0, option B, Q1 Q2 less than 0, option C, Q1 Q2 is equal to 0, and option D, 1 greater than Q1 by Q2 greater than 0. So in this case, how we can find the answer? Here we have two forces, both are attracting each other, means which type of force or which type of charge they will be. So which type of charge, how we can find that? Here the force is attractive, means the charges must be unlike. Okay, so in the case of unlike charges, which option will be correct? Q1 Q2 less than 0, that is positive into negative, so that will be negative. So that means Q1 Q2 less than 0. So the option B is the correct answer here. The option B, that is Q1 Q2 less than 0 is the correct answer. Clear? And now we can move to the second question. The question is, the electric potential on the axis of an electric dipole at a distance r from its center is V. Then the potential at a point at the same distance on its equatorial line will be, yes, the options are 2 volt, B minus V, then C, B by 2, and option D, 0. Here the electric potential on the axis of an electric dipole is given as V. Okay, then we have to find the potential at the same distance on the equatorial line. So in the case of equatorial line, which quantity will be varying? So here what is the equation for finding the potential due to this point charge, due to this dipole? Yes, here we have V is equal to 1 by 4 pi epsilon 0 P cos theta by R square, right? So V is equal to 1 by 4 pi epsilon 0 P cos theta by R square. It is along the axial line, right? So if we find it on the equatorial line, that angle will be, yes, 90 degrees. So theta will be 90 degrees. So what will happen for the equation here? Cos 90 is 0, right? So the answer will be 0. So the total potential at the distance r on the equatorial line will be 0. That is option D, 0 is the correct answer. Now we can move to the next question. The question is, temperature T, dependence of resistivity of materials A and material B is represented by figure 1 and figure 2 respectively. Identify material A and B. Here we can see two diagrams, that is the temperature dependence of resistivity of two materials are shown here, and by using this diagram we have to know that which are the materials, that is material A and material B. So the options are A, material A is copper and material B is germanium. Option B, material A is germanium and material B is copper. Option C, material A is nichrome and material B is germanium. Option D, material A is copper and material B is nichrome. Okay, so here we have to find the temperature dependence of resistivity of material. So what about metals? How the resistivity of metals varies with temperature? That we have already studied, right? That means the resistivity of metal, or in the case of in this question, copper is a metal, right? So the resistivity of copper or metal increases with increase of temperature. So here in which figure the resistivity increases as the temperature increases? Yes, that is figure 2. Here in the figure 2, that is material B, that is a metal. That means the material B is copper. Right, here the resistivity increases with increase in temperature. And what about the first case? Here we can see that in the case of semiconductors, the resistivity decreases with increase of temperature. So here in the first diagram we can see that, okay, here as the temperature increases, the resistivity decreases. That means the first figure is a, yes, semiconductor. That means here germanium is a semiconductor. So here we can see that resistivity of semiconductor decreases with the increase in temperature. That is, material A is germanium. So what are the correct options? Yes, option B is the correct answer. Right, here material A is germanium and material B is copper. Material A is germanium and material B is copper. That is, option B is the correct answer. Clear? Now we can move to the next question. The question is, a long straight wire of circular cross section of radius A carries a steady current I. The current is uniformly distributed across its cross section. The ratio of the magnitudes of magnetic field at a point distant A by 2 above the surface of Earth to that at the point distant A by 2 below its surface is dash. That is, the options are 4:1, option B 1:1, option C 4:3, and option D 3:4. So what are the things given here? Here we have a long straight wire and which is in the form of a circular cross section and which has a radius small letter A. Okay, the current passing through that is I, and here we have to find the ratio of magnitudes of magnetic field at a point distant A by 2 above and below the surface. Okay, so that first of all we can mark it with a diagram. So we can consider the diagram, and here we have a circular path and current I is passing through that. It has an area of cross section A. Okay, now we have to consider 2 points, that is P and Q. Here we can see that P, that is just above that means at a distant A by 2 from the surface of the wire. So that means A by 2 above means here we can draw this A by 2 above that, and from the center A by 2, that is below that, and A is the area of cross section of this wire. Okay, now we have to find the ratio, that is the magnetic field at P divided by magnetic field at Q. So for that we have to find the magnetic field at P. Then how we can calculate the magnetic field at P? So here we can use the application of Ampere's circuit, that is the magnetic field at point P, that is R is greater than A. Here we are considering that R is greater than A. So at point P, what will be the magnetic field? So for long straight conductor, we know the equation for magnetic field is mu 0 by 2 pi into I by R. Okay, so that is the equation for the magnetic field at point P. And at point Q, how we can find, that is the magnetic field will be just R will be less than A. Okay, so the equation will be mu 0 by 2 pi into I R by A square. So that also can be calculated by using this Ampere's circuit law. Here we can apply that. Then we are getting the equation B is equal to mu 0 by 2 pi into I R by A square. Right, that equations we have studied. And for the point P, what will be the distance R1? Here we can write that R is greater than A. So instead of R, we can give it as R1. Okay, and we know that R is greater than A means that will be equal to 3A by 2, A by 2 plus A. So that R1 will be equal to 3A by 2. So we can write P is equal to mu 0 by 2 pi into 1 by R1. And what about point Q? Here R is less than A. So Q will be equal to mu 0 by 2 pi into I R2 by A square. Here R2 is equal to A by 2 only. Okay, now we can substitute that. So what will be the ratio BP by BQ? Here we are finding that BP by BQ. So BP means here mu 0 by 2 pi will get cancelled. So remaining thing is 1 by R1 divided by BQ, that is I R2 by A square. Now we can substitute the value. So 1 by R1 into A square by I R2, right? So 1 by R1 means here we can give that 3A by 2 for R1. So what we are getting, A square by 3a by 2 into a by 2. So that will the similar terms will get cancelled. Then what we are getting, a square divided by 3a square by 4. Okay, so a square divided by 3a square by 4 we are getting. So that means the ratio is 4 is to 3. So here we are finding the ratio of magnetic fields at P and Q. Okay, so BP by BQ is found to be 4 is to 3. So what will be the answer? That is option C is the correct answer. That is 4 is to 3. The next question is, if the magnetizing field on a ferromagnetic material is increased, its permeability, the options are decreases, then option B increases, option C remains unchanged, and option D first decreases and then increases. So in this question, the magnetizing field on a ferromagnetic material is increased. So what will happen to permeability? So what is the relation between permeability and magnetizing field? Yes, in the case of ferromagnetic material, we have studied mu is equal to I by H. H is the magnetizing field. If H is increased means the permeability will be, yes, that will be decreased. So option A is the correct answer. That is, it decreases. That means as the magnetizing field increases, the permeability will be decreased. Clear? Now we can move to the next question. An iron cord coil is connected in series with an electric bulb with an AC source as shown in figure. When iron piece is taken out of the coil, the brightness of the bulb will, options are option A decrease, option B increase, option C remain unaffected, option D fluctuate. So which will be the correct option? So here the diagram is as shown in the figure, and here we have an electric bulb and which is connected to an AC circuit. Here we have connected an iron cord coil which is in series with the electric bulb. Okay, then when we remove that iron cord, that means an iron cord coil, then what will happen to the bulb? That means will the brightness increase or decrease? So that is the question. So how we can answer? As the iron piece is taken out, what will happen to the self-inductance of the coil? When the iron piece is taken out means when it is removed, what will happen? The self-inductance of the coil decreases, right? That means so omega L, that is XL, decreases. That means the current in the circuit increases. That means the resistance decreases means, or the self-inductance decreases means the current will be increased. So the brightness of the bulb will be increased. So which one will be the option? So the reason is only because the self-inductance of the coil decreases when we take out the coil. Okay, that means the iron cord coil. So what will happen? Self-inductance decreases. As a result, the current in the circuit increases. So the bulb means the brightness of the bulb will be increased. So the answer is option B, that is increase. Clear? The next question is, which of the following statements is not true about the properties of electromagnetic waves? So the question is from electromagnetic waves. Here we have to find the wrong statement regarding electromagnetic waves. First option is, these waves do not require any material medium for their propagation. Option B, both electric and magnetic field vectors attain the maxima and minima at the same time. Option C, the energy in electromagnetic waves is divided equally between the electric and magnetic fields. And option D, both electric and magnetic field vectors are parallel to each other. So which one is the wrong statement about this electromagnetic waves? So which is the wrong statement? If you have any doubt, you can just pause the video and read the options once again. Okay, then it is easy to understand the wrong statement. Which is the wrong statement? Yes, option D is the wrong statement. Here it is said that the electric and magnetic field vectors are parallel to each other, but actually the electromagnetic, in the case of electromagnetic waves, the electric and magnetic vectors are perpendicular to each other. That we have studied, right? So option D is the correct answer. That is the wrong statement. Okay, now we have the next question. That is, a rectangular, a square, a circular and an elliptical loop all in the xy plane are moving out of a uniform magnetic field with a constant velocity v is equal to vi cap. The magnetic field is directed along the negative z-axis direction. The induced EMF during the passage of these loops out of the field region will not remain constant for. The options are any of the four loops, option B, the circular and elliptical loops, option C, the rectangular, circular and elliptical loops, and option D, only the elliptical loop. So here what is given? A rectangular, then square, a circular and elliptical loop all are in the xy plane and which is moving out of a uniform magnetic field and the velocity is vi. Okay, so the magnetic field is directed along the negative z-axis. Then the induced EMF during the passage of these loops out of the field. So this is going to out of the loop because out of the field. It was in the uniform field and it is moving from that uniform field to outside. So which one will not remain constant? That is the question. So how we can answer? So which one will not be the same? So in this case we can say that when the circular and elliptical loops come out of the field, equal areas will not be traced by equal intervals of time. Because which one? The circular and elliptical loops. So for these two loops, the induced EMFs will not remain constant. So how we can answer? So in the case of circular and elliptical loops only. So which one is the correct answer? Yes, option B is the correct answer. That is the circular and elliptical loops. Okay, only the reason is when it come out, the equal areas will not be traced in equal intervals of time. That is why we can say that the circular and elliptical loops which are not remaining constant. Okay. The next question is, in a Young's double slit experiment, the path difference at a certain point on the screen between two interfering waves is 1/8 of the wavelength. The ratio of intensity at this point to that at the center of a bright fringe is close to, the options are 0.80, 0.74, 0.94 and 0.85. So what is given here? In the case of a Young's double slit experiment, the path difference is given. That means the path difference is lambda by 8, that is 1/8 of the wavelength. So lambda by 8 is the path difference, and here we have to find the ratio of intensity at this point to this center of the bright fringe due to fringe is close to dash. So here how we can find the ratio, that is I by I0 we want to find. So I by I0 is found to be cos square pi by 8. Okay, that is I by I0 means here I will be equal to I0 cos square pi by 4 by 2. Okay, so that will be I0 cos square pi by 8. When we calculate, we will get it as cos square pi by 8 is equal to 0.92 the whole square, that is 0.846, that is 0.85 is the correct answer. So the answer is found to be 0.85. Okay. Now we have another question. The work function for a metal surface is 4.14 electron volt. The threshold wavelength for this metal surface is dash. The options are option A 4125 angstrom, option B 2062.5 angstrom, option C 3000 angstrom, and option D 6000 angstrom. So the work function for a metal is 4.14 and threshold wavelength we have to find. So how we can find the threshold wavelength? Here work function is 4.14 electron volt, that is equal to hc by lambda, right? So hc by lambda we can write, that is equal to 4.14 eV. Then we have to calculate the threshold wavelength. So lambda 0 we have to find. So we can rearrange it. So what we will get, that is lambda 0 into 4.14 eV will be equal to hc. Right. So lambda 0 will be equal to hc divided by 4.14 eV. So how we can find? Yes, 6.6 into 10 raised to minus 34 is h, that into c is 3 into 10 raised to 8 divided by lambda 0 means the value is given, work function is 4.14 ev, so 4.14 into that value of one electron. So charge of one electron is 1.6 into 10 raised to minus 90. So when we calculate, we will get the value as 2.989 into 10 raised to minus 7. So 3000 angstrom. So the answer is option C, 3000 angstrom. Clear? Now we can move to the next question. The question is, the radius of the innermost electron orbit of a hydrogen atom is 5.3 into 10 raised to minus 11 meter. The radius of the n is equal to 3 orbit is dash. The options are 1.01 into 10 raised to minus 10 meter. Option B 1.59 into 10 raised to minus 10 meter. Option C 2.12 into 10 raised to minus 10 meter. And option D 4.77 into 10 raised to minus 10 meter. So here the radius of innermost electron orbit of hydrogen atom is given. That is 5.3 into 10 raised to minus 11 meter. Here we have to find the radius when n is equal to 3. So we can just substitute the value of n, that is r3 is equal to n square into r1, right? So that is n square means 3 square into r1 is 5.3 into 10 raised to minus 11 meter. So if we multiply that, we will get the value of r3, that is 4.77 into 10 raised to minus 10 meter. So the option is option D, 4.77 into 10 raised to minus 10 meter. So hope it is clear to you, because n is equal to 3, we are substituting in the equation. R3 is equal to n square into R1. Okay, so n square means 3 square into R1. Now hope it is clear to you. Now we can conclude the video. The rest of questions we can discuss in the next video. So thanks for watching.